We're going to continue our exploration of factoring algebraic expressions, specifically trinomials. Okay, so trinomials and specifically also of the form x squared plus bx plus c here. And so I'm going to emphasize this. I'm going to put a 1 in front of this. Anytime we have a trinomial where it's x squared plus bx plus c and our leading coefficient is 1, these tend to be very, very straightforward trinomials to factor, just because we see these all over the place. And so what I want to do is kind of explore the reverse of this before we start to take this apart as the product of two factors here. Let's take a look at a product of two factors that produces one of these and then talk about what we can observe. So we're going to multiply these two binomial factors here, x plus a and x plus b, and we're going to talk about what we observe about the final product here. And so because it's a couple binomials, right, we FOIL, and what we get is x squared plus bx. Okay, so I'm going to write plus bx here. And then we would get on our inner here ax, so we say plus ax. And then last but not least, we would get the product of a and b, and so we just say that is a and b here together. So what we're going to do is we're going to kind of rearrange this a little bit here, but this is x squared plus, and because I like to write things in standard form, so my exponent's going in decreasing order and being alphabetical, I'm going to put the ax before the bx just because, you know, OCD. And then the other part of this is, remember that when we FOIL two binomials of these forms here, we can combine like terms in the middle. And so this is going to seem kind of odd, but if I have ax's plus b more x's, then I have a plus b of those x's, and we can write this essentially as I have this many a plus b of these x's. And this is plus a times b. And so what can we observe about this product here, this trinomial here, x squared plus a plus bx plus ab, in comparison to this essential setup that we had up top, x squared plus bx plus c. And so what I want to do is I really want to look at these two values here. So the coefficient of our x in the middle term and then our constant term here. And what I notice is, let's look at our b value first. Our b value is equal to the sum of a and b, or whatever these two numbers here are. And so in other words, what we're doing is we're trying to find a b value here, or a middle term, that is the sum of these two values over here. And then our constant term here, when we look at it, you know, what can we say is true about our constant term? Well, it's the product of these two numbers that we see over here in these binomials. And so what we're really trying to do when we factor trinomials of the form x squared plus bx plus c is we're trying to find two values that go in these two binomial factors here that satisfy two conditions, that they multiply out to be our constant term c. Okay. And the other part is that they sum or add up to be our middle term here, which is our b value. So they sum to be our middle term coefficient, okay, is what I would say, coefficient. And I'll put comma b. So as we go through these, I'm going to kind of try to help you out here with some ways of looking at this or organizing your work, but essentially what we're going to be doing is recognizing that all of these expressions on the right are trinomials of the form 1x squared plus bx plus c, and that what we're trying to do is find a couple of binomial factors that multiply out to be this. And so what we know is that our binomial factors are going to be of the form x plus a, x plus b, and not necessarily both pluses, so I don't want to give that impression here, but there are some numbers that we're looking for to put here and here. And so these numbers have to multiply out to be our constant term here, okay? So negative 35, and they have to add up to be our middle term here, which is a negative 2. So one thing we can do is we can build a t-chart, and this is not something you have to do, but on the left here is what we can do is we can write our product. Products. And then on the right here we can write the sums. But essentially what we're going to do is we're going to write out all the different combinations that would multiply out to be a negative 35 on the left here. And so what I would do is I'd write like negative 35 times 1, but also a positive 35 times a negative 1. And then other combinations that produce a negative 35 would be like a negative 7 and a positive 5, or a positive 7 and a negative 5. Basically, you want to exhaust all possibilities. Now, this is a long way of doing this. A lot of times we just do this in our heads. But what we're also trying to ask is, are there any of these combinations that add up to be a negative 2, right? So what we're going to do is we're going to write the sum of these two factors on the left on the right column. And so negative 35 and a positive 1 would add up to be a negative 34, whereas a positive 35 and a negative 1 would add up to be a positive 34. So you see that they get the same value, same magnitude, but different parity or different sign, okay? When we talk about negative 7 plus a positive 5 is a negative 2, well, positive 7 plus a negative 5 is a positive 2. So we get these different combinations, and you can see that we actually found one that would do this here, okay, as a matter of fact. So what we're going to put is x minus 7 up here and x plus 5. And one thing I want to kind of iterate here is this. You can put x plus 5 and x minus 7. Multiplication is commutative. But one way to check yourself is just to kind of FOIL this back out, and you would see that you would still get this expression you started with here. So taking a look at letter B, let's kind of take a look at this. We say, well, this is a trinomial of the form 1x squared plus bx plus c. Let's say maybe it does factor, and I can build a couple of binomial factors here. So I get x and x. What are some numbers that multiply out to be a positive 25 but add up to be a positive 10? And this time, what I notice is it kind of sticks out to me that 5 times 5 would be 25, but also 5 plus 5 would be 10. And I could check this just by foiling these back out to make sure I get what I start with. I don't necessarily have to build this table here, even though I would find it to be maybe helpful some of the time here. Another thing I do want to mention on this one is it's kind of interesting. This is a special case where we have a factor times itself. And so you're going to see us talk about this as kind of our factor squared. And we tend to refer to these as perfect square trinomials because you can square a binomial to get it. Letter C, one thing I'm going to try to do here is kind of switch up our variable value here. That's not always x. Also, I want you to notice it's not yet in standard form. So it's always good practice to rewrite your polynomials into standard form here. And I see that this is a form 1x squared plus bx plus c. So let's build a couple of binomial factors and say, hey, look, can we find any values that multiply out to be a positive 24 that add up to be a positive 14? And it kind of, going in my head here, going through some factors here, I think that these would be really effective. And so we could get these two factors here and FOIL it and check ourselves. And then again on letter D, I want you to see something here. This is of our good form here. We're going to write our couple binomial factors, but what multiplies out to be a positive 12 that adds up to be a negative 8? And so the idea is going to be that because they multiply out to be a positive but add up to be a negative, they must both be negative at the same time because that would produce a positive product but a negative sum. So we would get a negative 2 and a negative 6. So our last one here, I just got to scroll down really quickly, and I want you to consider this is, every once in a while you're going to run into trinomials that maybe do something like this. So x squared plus 10x plus 4. And you're going to look at this and you're going to say, well, look, this is in this proper form. I know I'm supposed to have a couple of binomial factors so that this works. What are some numbers that produce a 4 but add up to be a 10? And it doesn't matter what I think of 1 and 4, negative 1, negative 4, positive 2 and positive 2, negative 2 and negative 2. This is never going to work. And so what we would write here is just that it's not factorable, or we would essentially just write that it is required. So that's how we factor trinomials of the form 1x squared plus bx plus c. I want you guys to practice this for next time.